So the first part of this is not new. It says to write the equation, and we have done that before, so I'm going to say y equals, and we have to look for the x-intercepts. I have two arrows, they're both pointing up. What does that mean? Positive coefficient, and the degree is even, okay? And then how many x-intercepts do I have? 2. So I have x equals positive 2 and x equals positive 4. X minus 2, x minus 4. Both to the power of 1, they have a multiplicity of 1. I can tell because they go straight through the x-intercept. So straight through, that means it has a multiplicity of 1. So this form is called the linear factorization. So we're going to go ahead and write that down. If you want to think of it as the factored form, you can. We call this the linear factorization. And we already spent a whole day doing that. Today we are writing the equation in standard form, which means today we start off like this and then we FOIL.
Oh, that's great.
Isn't that so fun? Because we love foiling. Don't we love foiling? All right, so let's go ahead and FOIL this out. We've got the first times the first, x squared. And then we have the outside, negative 4x. And then we have the inside. And then we have the last times the last, positive 8. So we have y equals minus 6x plus 8. And that's it.
That's all we have to do. There's nothing else up there.
That's it. However, they're not all going to be parabolas. Sometimes you have something like this. All right, y equals, we have our arrows going opposite directions. Goes up first, then down. What does that tell you? Negative. It's got a negative slant to it. We have an x-intercept at -1. Sorry, that's a negative, -1. And we have an x-intercept at positive 3. So what should I have? Okay. So x plus 1 to the power of 1, because that's a multiplicity of 1, it goes straight through. X minus 3 to the power of 2, because when it hits that x-intercept, it bounces. It means that that answer happened twice. Okay, and if you guys remember from what we did when we did the color by number worksheet, we were saying whatever the highest exponent is, whatever the degree is, that's how many answers you have, right? And so this is a degree of 2, which means we had 2 answers, 2 and 4. So they match, right? Like they should. Okay, so here we have to FOIL now. So what I'm going to do is I'm going to write down all the parentheses. So I've got x minus 3 needs to be written twice. And when we have 3 things to multiply, we have to do the problem in pieces because we can only multiply 2 things at one time. So what 2 things would you like to multiply first? Say it again. The first 2? So I'm going to leave the negative. I'm going to go ahead and we're going to FOIL these together. So I have first times first, x squared. Then I have the outside. Then I have the inside. Then I have the last, minus 3, okay? And then I'm going to put the negative in the front, put the x minus 3 on the end. Okay, if I combine like terms, what do I have? Okay. Now, I would say that most students have a hard time FOILing stuff like this when there's more than 2 terms times 2 terms. two terms times two terms like this is pretty easy. Anything more than that is more difficult. So what I like to do is use a box to multiply it. So I have 3 terms multiplied by 2 terms. So that means that when I make a box, my box has to be 3 terms by 2 terms. So there's 3 by 2. So I have x and a negative 3. And then I have x squared, negative 2x, and negative 3. Yes, I do this for myself too. I don't like foiling if it's more than 2 times 2. So what is x times x squared? X cubed, so that's what goes in the first box. What is x times negative 2x? Negative 2x squared. And then what's x times negative 3? Negative 3x. Okay, go ahead and fill out the other 3 boxes. All right, so what did you guys get in the next 3 boxes? Okay, so we have y equals negative. I can't forget that I have that negative in the front, so I still have to keep that negative in the front. And then the nice thing about multiplying using a box is that your like terms end up being on diagonals, and so they're a lot easier to combine because they're all right next to each other. So we have x to the third, and then we have a negative 3x squared and a negative 2x squared, minus 5x squared, and then we have a 6x and a negative 3x, plus 3x, and then plus 9, okay? And then what do I do with that negative? Distribute. So negative is going to change all the signs. So actually I'm going to write it up over here. So that means that y equals, and what do I have? Perfect. Okay, so there is our equation. This is a cubic, x to the third. So we expected to have 3 answers, and we did. We have the answer negative 1 one time, and the answer 3 2 times, and so that adds up to 3 answers. All right, let's go ahead and look at the next one. What do you guys see with the next one? We have 4 X intercepts. So we have x equals negative 5, x equals negative 1, x equals 3, x equals 4. And so how do I write that?
X plus 5, x plus 1 in parentheses. These are all in parentheses. X minus 3, x minus 4.
All to the power of 1. So it goes straight through, straight through, straight through, straight through. These are all to the power of 1. So this time we have 4 parentheses. How do we do this one? Yeah, we can do 2 and 2. Yeah, so we're going to go ahead and FOIL these 2 and see what we get, and FOIL those 2 and see what we get. So I want you guys on your own paper to go ahead and FOIL each of those while I staple your assignment. Look at that, we're multitasking. So when you FOILed the first two, what did you guys get? X squared plus 6x plus 5. Is that what we got? Yes? Okay, and then when you FOILed the second two, what'd you get? Okay. So we have 3 terms times 3 terms. So we're going to use a box this time. And how big does our box need to be? 3 by 3. So we have x squared, 6x, 5, x squared, negative 7x, 12. It doesn't matter if you switch the sides. Like if you happen to write the 7x minus, or the x squared minus 7x plus 12 on this side, that would have been fine. You'll get the same answer. So x squared times x squared is x to the 4th. X squared times negative 7x, negative 7x cubed. 12 times x squared, 12x squared. Okay, go ahead and finish filling out the box. So we've got 6x to the 3rd minus 42x squared. 6 times 12? 72. 5x squared minus 35x, 60. Okay, so when we write that out, that is y equals a lot of stuff, but all the like terms are in the diagonals. So what do we put first? X to the 4th. Then we have 6x to the 3rd and negative 7x to the 3rd. So minus x to the 3rd. Then we have 5x squared, negative 42x squared, positive 12x squared. Well, these two together would be negative 30. Negative 30 plus 5, negative 25. And then negative 35 and positive 72. Positive 37x, and then plus 60. So it was x to the 4th. We expected to have 4 answers, and we did. We had negative 5, negative 1, 3, and 4. 4 answers total. That fits. Okay, so if you look at your assignment, there are some more like this, and you just have to be really careful. Like on this worksheet, we had 2 problems that were positive, so we didn't need to distribute the negative at the very end. But we did have this example that had the negative in the front. So if you need to have a negative coefficient, how do you handle that? Yes, save it until the very end. It's not that you can't do it before that, it's that students usually make mistakes. It is the easiest to deal with the negative at the very end, okay? I like to teach you the easy way sometimes, and the very end is the easy way. Sometimes. sometimes I'm like, gotta teach you the hard way today. Torture you. Yeah. All right, so go ahead and work on this one. Oh, look, it's basically the same thing. Isn't that fun? Christmas, right? Marvelous. We're going to keep doing the notes. We're just going to practice for a little bit first. The notes are. So when you guys are looking at problems like this is what x-intercepts look like when the problem was factorable and you can find nice whole number answers, okay? So you end up having nice x-intercepts. But sometimes we would find our x-intercepts by using the quadratic formula. And when we use the quadratic formula, we could get decimal answers, right? You could do like the square root of 21, which gives you a decimal, and then you'd have to graph like a decimal for the x-intercept. Or when you did the quadratic formula, you could take the square root of a negative, and then what kind of x-intercepts do you have there? Imaginary. So the answers I get when I solve for the quadratic formula are irrational. That's what it's called when you have those messy decimals. So irrational, that would be like if you had like the square root of 7 or something. Irrational and complex answers. And complex answers are the ones that have a portion of the answer that's imaginary. So weird square roots or something with an I in it. And because the irrational and imaginary answers come from the quadratic formula, they always have a plus minus. They always have a plus minus. Two answers, not just one, but two, always. So the positive version of the square root, the negative version of the square root, okay? So if we write the quadratic formula, we have x equals negative b plus or minus square root of b squared minus 4ac all divided by 2a. And that plus minus right there is what makes it so we have two answers, okay? So we have two answers. That means that when we have weird x-intercepts or imaginary x-intercepts, they always come in pairs. Positive version, negative version. So what I did here is I gave you a picture where they would have had x-intercepts that came from the quadratic formula. They did not come from factoring, they came from the quadratic formula, which means the x-intercepts are not very nice. They're weird decimals. Okay, so here they said x equals negative square root 2, and then here we have x equals positive square root 2. So if we do the same thing that we did on the previous page, then what should I be writing? So x plus square root 2, x minus square root 2. Both arrows go up, so what does that tell me about the coefficient? Say it again. Well, to the power of 1 is because they go straight through, right? Multiplicity of 1, multiplicity of 1. But when both arrows go up, what does that tell me? It's positive. It's got a positive coefficient. Okay, so to write the standard form, this is the linear factorization. To write the standard form, I have to FOIL. So I have x times x squared. Then I have x times negative square root of 2, which is negative square root of 2x. And then I have positive square root of 2 times x, which is positive square root of 2x. And then I have positive square root of 2 times negative square root of 2, which is negative. And then what's 2 times 2? 4. So this is negative square root of 4. Okay, so what happens with these two? They cancel out. What's the square root of 4? 2. So I have x squared minus 2. So even though the problem felt like maybe it was going to be a messy problem when we got started, it ended up being really nice. It didn't work out badly. Okay. All right, so the next problem, it doesn't give us a picture because they can't. They have an x-intercept of -3i. So there's no picture they would have drawn for that because it doesn't actually cross the x-axis. So we're going to go ahead and say we have x equals. This says it's a second degree polynomial. That means we're going to have two answers, x equals, x equals. They told us that one of the answers is -3i. So the other answer has to be +3i. Because we know that imaginary answers always come from the quadratic formula and that they have to have two, one plus version, one minus version, okay? So I'm gonna go ahead and put it in parentheses just like the other problems. I have y equals, for the first one I have x plus 3i. For the second one I have x minus 3i. And then just like all the other ones, we're gonna go ahead and FOIL. Now here, since they wrote it in a sentence, if it had a positive coefficient or a negative coefficient, and so if they don't tell us, we just assume that it's positive, okay? All right, so I start to FOIL this, I get x times x, and then I get x times -3i, yeah, -3ix, and I have 3i times x, positive 3ix, and then I have positive 3i times -3i, it's -9i squared, okay? And then what happens with these two in the middle? They cancel. Does anyone remember what I squared is? It's a -1. So we have a -9 times a -1, which is 9. So we end up with x squared plus 9. And what am I missing? Y equals? Oh, you guys. So be careful to watch for that y equals. I want to make sure we have an equation at the end. On these problems, missing the y equals is the most common missed point on the test. If somebody gets something wrong, it's most often that they forgot the y. Okay, so we had an x squared for a second degree, and it had two answers. X squared, degree of 2, two answers. It all matches. Okay, so the part you need to remember is that when the answers look messy, the problem should still clean itself up and look nice at the end, okay? All the problems, when you get done at the end, they should look nice. They should be clean. You should never have a square root in your answer. You should never have an I in your answer. They always clean up to be nice numbers, okay? So this one says we have a third degree, so I'm going to say x equals, x equals, x equals. I'm going to have three answers because my degree is 3. It says it has a root of -2 with a multiplicity of 2, which means that that answer happens twice. -2 and -2. And then they have a root of 1 with a multiplicity of 1, so we just have x equals 1. So this is how you write the sentence form of a picture that looks like this. They said they had one root with a multiplicity of 2 and one root with a multiplicity of 1. So here you saw it in picture form. Over here, we're looking at the exact same thing, but in sentence form, okay? So let's go ahead and write the parentheses. What should I have? X plus 2, x plus 2, they're the same, because it was a multiplicity of 2, so they're exactly the same. And then x minus 1. And how do we work with this one? Yeah, so we have x times x, and then we have our outsides, and then we have our insides, and then we have the last. Dylan, I might snap your leg off. Thank you. I wouldn't actually snap your leg off, but the sound was getting to me. All right, so I have x squared plus 4x plus 4. Okay. Yep, I would do a box because I don't like foiling these. Did anyone try foiling it?
Yeah.
Did you like it?
Yeah.
You liked foiling it? You guys are crazy. All right, so we got this. I mean, but I support you. If you want to foil it, feel free to foil it. Mm-hmm. Did everyone get their y equals? Okay, so we have x to the third plus what? Plus 3x squared. Wait. Yeah, 0x, so I'm not even going to write it, and then minus 4. If you want to put 0x, you totally can. It's not wrong to do that. Okay. We gotta keep going. Well, I want you to go ahead and try number 7 and number 8 on your packet. 7 and 8. So that's what you're going to go ahead and try right now. So this one says second degree polynomial. So how many times do I write x equals? 2. So x equals and x equals. And this answer came from the quadratic formula. It has 2 plus 5i. So if we write the other version of the answer, what would the other version of the answer be? 2 minus 5i. So if you notice, the 2 stays the same. That doesn't change signs. And that's because when you do the quadratic formula, the plus minus happens in the middle of the problem. It doesn't happen in the front. So the 2 from the 2 plus 5i, that 2 must have been the negative b part in the very front. And then the 5i came from the square root. So we only change the sign in the middle when it looks like this. Okay? 2 minus 5i is not 2 different answers. That is one answer together. It's a complex number, so it has a real portion and an imaginary portion. It's both together. Okay? So x equals 2 plus 5i, x equals 2 minus 5i. So if I put this in parentheses, I still have to do the opposite sign. So for the first one, I have x minus 2 minus 5i. And for the other one, I have x minus 2 plus 5i. Does that make sense? Okay. So we have 3 pieces multiplied by 3 pieces. So I'm going to go ahead and use a box. If you want to foil, you can foil. And while we're doing this one, things get pretty messy in the middle, but they clean up nicely at the end. Okay, so again, I should never have an I in my equation. I should never have a square root in my equation because they always clean up nicely and go away. So x minus 2 minus 5i, x minus 2 positive 5i. So I have x times x times negative 2, x times 5i, 5ix, yep. So that one is messy, but it's going to go away. You'll see in a second, it'll go away. Negative 2 times x. Negative 2 times negative 2. Negative 2 times 5i. You're close. Negative 10i. So that one's messy, but it's going to go away. You'll see in a second. Negative 5i times x. Negative 5ix. Negative 5i times negative 2. 10i. And negative 5i times positive 5i. Negative 25i squared. Okay, so if we focus on the messy ones, 5ix and negative 5ix cancel out. So those two are gone. Negative 10i and positive 10i cancel out. So those two are also gone. And negative 25i squared is like saying negative 25 times negative 1. So that's just 25. So we have y equals plus 29. So the 4 and the 25 we added together, and that's where we got the 29 from. All right, last example. They tell us that one answer is 4i, so I'm going to say x equals 4i and x equals negative 4i, okay? And then they tell us another answer is negative 3 root 6, so I'm going to say x equals negative 3 square root 6 and x equals positive 3 square root 6. So for this one, it's kind of like the b value is 0, and they just had a positive square root and a negative square root. Do you guys know how they got the number 3 in the front? The 3 was already in the front like that. Yeah, they simplified the square root. So it means the square root was like a bigger number, and they did like the little factor tree, and they simplified the square root. Okay. Okay, so if we put this in parentheses, we would have x x minus 4i, x plus 4i, x x plus 3 square root 6, x minus 3 square root 6. Okay, so if you're crazy, maybe you'll try multiplying those, but one of the honor students tried it and it took him 45 minutes, so please don't do that. Yeah, you can do it if you want, but you're crazy. All right, so let's multiply these two together, and we'll multiply those two together, because when we multiply the messy ones by their pair, everything works out nicely, as long as we multiply it by the one it goes with. So x times x times positive 4i, okay, negative 4i times x, and then negative 4i times positive 4i, 16i squared. Okay, so what happens? Those cancel, and it's negative 16 times negative 1, which is positive 16. So that one cleaned up real nicely. X squared plus 16 is a nice answer to work with. Okay, over here we have x times x, and we have x times negative 3 square root 6. Oop, square root 6. X, okay. And then we have positive square root 3 times x. So positive 3 square root 6, x. And then we have 3 square root 6 times negative 3 square root 6. What is 3 times 3? 9. So I'm going to say minus, I've got 9 times square root 6 times square root 6, square root 36. Okay. So what happens with these two? Those are gone. Okay. So we have x squared minus 9 times, what's the square root of 36? 6. What's 9 times 6? Okay. So if you didn't like, I did this in my head, right? I had us do it by hand instead of do it in our calculator, but your calculator could have handled it just fine. So you could have done 3 square root 6 times negative 3 square root 6, and it would have taken you straight to negative 54, and you didn't have to do it by hand if you didn't want to. Okay? All right. But a lot of students wonder how they would have multiplied those, and that's how I did it. So I multiplied the number in the front. 3 times 3 is 9. And then square root 6 times square root 6 was square root 36. And square root of 36 we said is just 6. Okay, so what do I do with these two? I FOIL them, and it's 2 times 2, so I can just do like normal foiling if I want. So x squared times x squared, x to the 4th, x squared times negative 54, positive 16 times x squared, and then positive 16 times negative 54. Okay, so we have y equals, because we're never going to forget that y equals, right? Y equals x to the 4th. You can put that if you want, yeah. You don't have to, but you could. And then how many x squareds do we have? Negative 38. And then negative 864. What problem does this kind of remind you of? In the packet. It should remind you of number 8, yeah. It's very similar to number 8. All right, so at this point, you have 20 minutes. You are working on the packet. The packet is your homework tonight. So that's your job, is to finish the entire assignment packet. Okay?